In this video, we're going to talk about calorimetry. Start talking about calorimetry anyway. Particularly, we're going to talk about specific heat and heat capacity. Two similar subjects, but they're different, ever so slightly different. Calorimetry is the measurement of heat changes. And the device that you use to measure those heat changes is called a calorimeter. In order to do the calculations involved with calorimetry, we need to understand specific heat and heat capacity. The specific heat of a substance is the amount of heat required to raise the temperature of 1 gram of the substance by 1 degree C. So the specific heat of a substance is the amount of heat, which we measure in joules, required to raise the temperature of 1 gram of the substance by 1 degree C. So you can see the table below that specific heat has the units of joules divided by grams degrees C. So joules over grams degrees C. And every substance has its own unique specific heat. And so you can see the table down below that aluminum has a specific heat of 0.9 joules per gram degree C. Gold 0.129. And so which one absorbs heat better or heat more? And so the aluminum absorbs it much more because it has a higher specific heat. Water has a specific heat of 4.184 joules per gram degree C. Because of its high specific heat, it enables life to be as it is here on Earth. Specific heat is important in the kitchen. You'll have copper bottom pots and pans, and the rest of it's made out of aluminum. Why would you do that? The higher the specific heat, the slower will be the amount of heat that can get transferred over a given amount of time. And so we have copper bottoms. Copper only has 0.385 joule per gram degree C specific heat because it will allow the heat to be transferred much faster to the food that we're cooking in the pot. But we don't make the whole pot out of copper because that would be too expensive. And so we can cut down the cost by using aluminum for the rest of the pot. So the bottom is copper, the rest of it's aluminum, and we're doing good chemistry there by using substances with different specific heat. Heat capacity is different. It's the amount of heat required to raise the temperature of an object by 1 degree C. Not a given mass, but an object. So we're not going to have mass in the denominator, in the units for heat capacity, whereas we did for specific heat. So the object may be a given quantity of a particular substance, or it could just be a pot or pan or whatever that you might be looking at. So if you take the heat capacity of 1 kilogram of water, for example, that would be 4.184 joules per gram degree C. That's the specific heat. And remember, it has units of joules per gram degree C. Multiply that by 1,000. So you're taking the specific heat of a substance, multiply it by a mass, and we wind up here with 4,184 joules per degree C. There's no grams, no mass unit in the denominator in this one. So sometimes we'll use specific heat if we were given a mass, and that's the key to be looking for in problems. Other times we'll be using the heat capacity, as it just has units of joules per gram degree C. So let's look at a problem in just a moment, but there are two different formulas we're going to be using. One is Q is heat, is equal to the specific heat times the mass times the change in temperature for the process that we're looking at. Remember, when we're looking at changes, always final, nice, initial. And the other type of problem we can use is that the heat of a process is equal to capital C, and this is the heat capacity. So lowercase s is specific heat, capital C is heat capacity. So heat is equal to heat capacity times the change in temperature, which is, once again, T final minus T initial. And M is mass, And S is specific heat. Delta T is a change in temperature, T final minus T initial, and C is the heat capacity.